make a start. I dare say some people will pop in as we begin, but yeah, we'll just get going, I think. So welcome everybody to this Future Urban Ventilation Network seminar. This will be the last one of this year. They'll start again in January next year. So very pleased to welcome Professor Alison Tomlin from University of Leeds. Alison is head of the Clean Combustion Research Group, has a range of areas of expertise, including combustion, air quality, renewable energy technologies, modelling and uncertainty quantification, analysis of chemical kinetic systems. So the title of her talk is Possible Impacts of Low Carbon Heating Strategies on Indoor and Outdoor Air Quality. Alison, I'll hand over to you.
Thanks very much, Tim. So yeah, I was just saying to Tim before we got started that when I suggested this topic, I sort of felt like I suggested it because not enough people were talking about it, and now I think due to the energy crisis and rising energy costs, then everyone seems to be talking about how to heat their houses. So it's quite a broad topic, and what I'm going to do today is give a review really, rather than talk about particular research projects that we've been involved in, and talk about mainly the sort of interactions between different choices that we will have to make around heating our houses in the future. Okay, I can't seem to get, that's right. So, I mean, I think we're probably all in agreement that there's an urgent need to decarbonise the UK heat sector. Heat accounts for quite a large proportion of greenhouse gas emissions for the UK, 37% overall, and quite a large proportion of that is from the domestic heating centre, with also process heat making quite a large contribution. And we've seen, of course, recently that global supply issues for gas that we mainly use for heating in the UK is affecting pricing, and suggests really that the main solution in terms of decarbonisation and also pricing is to get ourselves off gas, and also to reduce our overall demand for heat. Sorry, I'm trying to, that's right, I'm trying to minimise so I can see my whole slides. Good. So we've got various different options for low carbon heating that I will touch on today. That includes electrification of heating, which is probably going to be the main route for decarbonisation for the UK. So heat pumps are mentioned briefly, and also storage heaters. And then there are other alternative fuel systems that we can think about. So still combusting fuels, but obviously decarbonised fuels or fuels which might be carbon neutral. I guess it's become a fairly controversial topic as to the direction that we should go as a country, and direction choices for individual households. So alternative fuel systems could include hydrogen, so put an early generation hydrogen boiler here, use of biomass, which is solid fuel or can be used in gasification processes, but also biofuels and potentially even synthetic fuels. Heat networks are something that we use to a small extent really in the UK. Heat networks are basically a way of delivering hot water and heat to households, and can be dependent on various different ways of producing that heat. So it could be electric, or it could be combustion based. And then we might have hybrid options, which combine some of these options that I've talked about above. And what's interesting is that all of these different options have different overall energy system requirements. And so heating sits really within the kind of overall demand for energy within the UK. So if we go through a process of electrifying heating, then of course that will increase electricity demand, although it will reduce domestic gas demand. And so the choices that we make will impact on how we deliver energy to our houses, either through future gas systems, which might be hydrogen, or through increased delivery of electricity to power heat pumps. And each will have different possible impacts on emissions of air pollutants, both at the domestic scale, but also maybe at the heat generation scale. And that's, I guess, one of the things I want to focus on today. And all of these different systems may also have different requirements for large infrastructure, as well as modifications to households. And the reality is, what we're all going to have to do this. I mean, like most people, I guess at the moment, I've still got a natural gas boiler, and I'm trying gradually to reduce demand so that I can switch to different option. And we will all have to do this in the long run to decarbonise our heating systems. Sorry, I'm having a bit of problem moving slides. I don't know why. Okay, here we go. So I'm going to talk first about the challenges for the UK in terms of legacy housing that we have and our legacy ways of heating our houses. And then I'm going to review, I guess, how well we're doing in terms of energy efficiency, and you can probably guess what the conclusion is there. It's not as well as we should be or we need to be. And then I'm going to talk about delivering primary heat through heat pumps, hydrogen heat networks. And then I'm going to talk about perhaps the interactions between choices that we might make about primary heat delivery and secondary heating, and how both of those can impact on air quality. I mean, at the end of the day, what we're looking for perhaps is synergies between solutions that will lower our carbon footprint and therefore tackle climate change challenges, but will also reduce local air quality. So we're looking to, I guess, to find the win-wins. And the little plot that I've put on the right there is basically just looking at the interactions that we've got in the system. So at the centre, really, we've got the overall energy demand and overall pollutant emissions that will come from different choices. But the choices that we make will also interact with infrastructure requirements, both at the national scale and domestic scale, the costs of delivering heat to domestic properties, local and indoor air quality, and behavioural factors, and the embedded views that people have about how they want to heat their homes, I think will also have an influence on the choices that people make. So what are the challenges for the UK? Well, unfortunately, there are many. We do have very leaky houses in the UK. We have a lot of older housing stock that hasn't been retrofitted to the extent that it should be. So we have fairly leaky homes, and the plot on the right here shows once we've heated our internal houses to a temperature of 20 degrees, if it's cold outside, then how much heat do we lose after 5 hours? And you can see that a typical house in Norway loses less than 1 degree, whereas a typical house in the UK will lose 3 degrees. And so a quick look at the colour scale there shows you that we do have the leakiest houses really across Europe. And the plot on the left is suggesting, these are based on old energy prices actually, that we have the highest proportion of fuel poverty across Europe. We spend the largest share of our household income on energy, and we have a high number of people living in poor repair homes. And of course, the increasing gas prices and the energy crisis has worsened this position. So one of the problems I think that the UK has is that historically we have had, I suppose, abundant supplies of natural gas that came from North Sea reserves, which we don't necessarily use now, but it's led to, I think, a legacy reliance on high temperature domestic heating systems. So the UK is here on the right of this plot, and the grey is a natural gas. So you can see that the largest proportion by far of our contribution to heating is from natural gas, a small proportion from electric at the top there, and also from oil at the bottom. I mean, we're not necessarily alone in this situation. The profile for Italy looks fairly similar, and that of the Netherlands is also similar. The red here are district heating systems, and you can see that the Scandinavian countries, so Denmark, Finland, Sweden, and to a certain extent Germany and Poland, have much higher proportions of delivery of heat through district heating systems, and some countries also have slightly higher proportions of electrical heating, so France, Germany and Spain. But in the UK, we have been reliant for many decades on natural gas to heat our houses, and to a certain extent oil. And also, we were encouraged for efficiency purposes to switch to combi boilers for our natural gas, and so we got rid of hot water tanks in our houses. So we don't really have the ability to store heat in most houses. And we like to have small radiators that don't take up too much room, and so in that sense we're poorly set up really for using lower grade heat that might come, for example, from the use of heat pumps. So we have significant challenges in the sense of we have a very slow uptake of electric and district heating systems. We have had some schemes that have tried to incentivize lower carbon heat options. So the renewable heat incentive survived for several years and provided support. It was a bit like a feed-in tariff. So if you generate heat from lower carbon sources, then it would give you back an annual repayment. And there are many different options included in the RHI. So heat pumps were included actually. But most of that money went to biomass systems, in fact, and larger scale biomass boilers, particularly for semi-commercial enterprises. So in the sense of cleaner, lower air pollution systems, the renewable heat incentive was not massively successful, and the scheme has now been retired, I think in March this year. New scheme is the boiler upgrade scheme, which offers an upfront payment, so £5,000 off the cost of a typical air source heat pump if you use a registered installer. And the pot, as is the one with this country, is a limited amount of money, which covers a maximum of 90,000 homes, whereas the Committee for Climate Change suggests that we need to be getting to 600,000 heat pump installations a year if we want to keep in line with our net zero targets. And so this is challenging financially for most people because the upfront costs of a heat pump at the moment are likely to be of the order of £8,000 to £12,000. So even with the £5,000 off the cost, that's not within many people's budgets. And at the moment, there's been a slight shift, I think, to make electricity marginally, the increase in prices have been more for gas than electricity, but electricity is still much more expensive per kilowatt hour than gas. And so we're not necessarily incentivizing electricity for the use of heat in that way. So that's another challenge. So let's see kind of how we're doing in terms of the different aspects of this that I talked about at the beginning. So demand reduction and then different options. Are we insulating Britain? I mean, obviously there's been a lot of campaign work around the need to insulate Britain. So how are we actually doing? I mean, the short answer is we're not really doing very well. I mean, ideally from a heat maintenance perspective in houses, we're aiming to get close towards passive house. I mean, a typical passive house will have high levels of weatherproofing, high levels of insulation, possibly mechanical ventilation with heat recovery to improve the flow of air around the house and to reduce humidity, for example. And all of these things contribute towards reducing the demand for space heating and cooling requirements and increasing the level of comfort within the home. But the reality is that currently there are only about 1,300 passive houses in the UK, and so that's a really, really small percentage of homes in Britain. Additional to that, requirements for new builds are actually lower than they have been previously, and so demands for the requirements on new builds are not as demanding in terms of getting close towards a passive house situation as they used to be. Sorry, I don't know why my slides won't move on. Okay, here we go. So what about retrofitting our homes to reduce demand? I mean, this is obviously a direction that we need to head in. How far should we go? I mean, I don't know about you, but I'm sort of asking myself personal questions about this for this house. And I'm going to run a poll in a minute to see how you're all doing on this, actually. So we've got various different levels of retrofitting that can help reduce heat demand. Top-up loft insulation, well, you would imagine that every house in Britain has that, but it's actually not true. Reducing drafts in the home and improving air tightness, and cavity wall insulation. These are all relatively low-cost, low-hanging fruit options for reducing heat demand, which you would imagine we should be prioritising for every house in the country. And then we move on to slightly more expensive options. So in double or triple glazing, relatively high costs, underfloor insulation, we're running into thousands of pounds. And then internal and external wall insulation, again, probably of the order of a couple of £1,000 and upwards. So there are sort of degrees of expenditure in terms of reducing demand, which will of course impact on how long it will take in terms of energy bill savings to actually recoup the investment that you make at the beginning. And then of course we can add renewable power supplies, so solar PV or solar thermal, and then finally move towards replacing a heating system with something like an air source heat pump and a thermal store. So I think in terms of how we're doing, well, unsurprisingly, perhaps there was a shift in policy around 2010. No guesses for what happened then, and since then, support for improving retrofitting of housing was withdrawn, and therefore the number of houses that went through significant energy efficiency measures really fell off a cliff and has been declining ever since. And the EPC system does get some criticism, and whether its suitability, setting that aside, the reality is that most houses in the UK do not meet the EPC C level target. And so the average rate of renovation that we need to get our houses to the targets required in pathways to net zero is something like 1.2 million a year, and we're well below that target. And so Committee for Climate Change has shown that we're very off track really in terms of improving our energy system. And the incentives that we've had in recent years, so the Green Deal and the Green Home Grant, really weren't particularly appealing to householders, and therefore weren't really that successful. I mean, just to show how quickly a field this is in terms of movement. Of course, last week there were announcements from the budget that £6 billion will be made available for energy efficiency measures. I mean, it's slightly lower than what was in the Conservative Party manifesto, but it's a reasonably significant amount of money. So it'll be interesting to see how that will be implemented over the coming years. I mean, the problem with poorly insulated houses is, of course, they're losing a larger proportion of the heat that you're actually generating, and therefore energy costs will depend on the level of energy efficiency that you have in your home. 59% of homes in England are of energy band rating D and below, and these are based on older energy prices from 2019. But this report from the Institute of Health Equity shows that most of our houses have pretty high energy costs in terms of heating, and the lower the level of retrofit in the house and the higher the heating costs. So if you have a fairly energy efficient house with fairly high levels of retrofit, then 2019 prices, you'd be spending £1,000 a year on energy. I mean, that's probably double now, right? If you have a house of poor retrofit in the G category, then you're spending 3 times that amount. And unfortunately, older homes, which could be occupied by older people, and maybe rental homes, are more likely to be in these worst categories for energy efficiency. So the Committee for Climate Change have kind of suggested where we need to be in terms of improving the level of retrofit of our houses, and therefore improving overall demand for heat. And this is where we need to be headed, you know, to looking at installations of a couple of million per year, peaking towards the end of this decade. And this is basic stuff. This is basically loft insulation, cavity walls, and then the yellow at the top there is solid wall insulation, which comes at a much higher cost. But it's perhaps surprising to see how many, how little loft insulation and cavity walls, how many houses do not have this level of retrofit. So I think actually at this stage, I'm going to run my poll and see from the participants of the group that are here, what level of retrofit you have in your houses and what type of heating you have. So if you humour me, maybe fill out these 3 questions. So I'll launch a poll. The first question is, what following forms of insulation do you have in your home? So we'll see, a very small poll of about 30 people where we're at in this group. What type of windows you have, and then what type of heating choices do you have. So please tick all of the ones that apply for questions 1 and 3. So I'm going to launch it now and see what happens. So Helen, if there's a problem, can you see the poll?
I can see the poll, but I can't click on it.
You can't click on it?
Everyone else can.
Really?
I can click on it, Alison.
Okay. Ignore me then.
Well, no,
I have very thick curtains in my house. That's
0 participation so far. So.
There we go. People are going in.
Oh, you,
It's
Mickey.
filling out.
All right, there's some answers coming in. I guess I was kind of expecting that maybe an informed group like this might be slightly higher than average in terms of retrofitting, but we'll see. I want to see if anyone's going to fess up to having a multi-fuel stove. Whoa, okay. So just to let you know how it's going, 75% of people so far have loft insulation, which is good. Only 30% of people have draft excluders. And 20% have cavity wall. Wow, okay, that's low. So just give it another minute. I think most people have answered now. Chimneys and stove now disabled. Oh, I'd love to read that comment. Okay, is everybody done? I think that's nearly 90% participation, so that's brilliant. I'm going to end the poll, so if you're still thinking about it. That's been really interesting. I don't know, I hope I can share the results, but maybe. Can everyone see that?
Yes, we can see that.
Yeah, we can see it.
So just to give you some feedback then on the answers that we've got. So 75% of people have loft insulation, which is great, but actually below that, the maximum is 25% in terms of draft exclusion, any internal wall or underfloor insulation or cavity wall insulation or external wall insulation. These are quite low levels, I guess. So loft insulation is the most common, obviously. It's also the cheapest form of retrofit, and everything else then less than 25%. Most people have double glazed windows, so that's obviously good news, or mostly double glazed. just 13% single glazed windows. And then interesting question around secondary heating, which will become more relevant later. So, 33% of you, no, 37% of you have some form of solid fuel secondary heating, which is quite interesting. 22% with gas fire, plug-in electric heater or no secondary heating is 48%. Okay, so there's a kind of about a half and half mix. Well, not many people have a gas fire, and then the rest is split between solid fuel or no secondary heating or electric secondary heating. Okay, so I'm going to look at there. Thanks everyone for taking part in that. That was really interesting. Hopefully you'll see the relevance of that as I carry on. So the question is, I suppose, how far should we go down the retrofit road? And so depending on what newspapers you read, I guess there'll be different stories of saying, well, if we're all going to be forced to get a heat pump, then do we need to spend £20,000 on retrofitting our houses to make the heat pump work? And BEIS actually have done a study recently, again based on older energy costs from 2020, but looking at the cost optimal options for decarbonising heating for a range of different houses. And so I just included one plot here, but they looked at various different types of properties, from a small flat on the left. I just need to get my pointer back, don't I? A small flat on the left through to bungalows, semi-detached houses, and then large detached houses on the right. And what they were looking at was, well, if we're going to move to electric heating, could be different options, both low temperature, high temperature, air source and ground source heat pumps, or storage radiators for some properties, and then a range of different retrofitting options. So starting with the cheapest, which most of us have, the top-up loft insulation, and then moving through to cavity wall insulation, draft reduction, and then on to underfloor insulation or internal or external wall insulation measures. And what they found, they used a 20-year payback period based on 2020 energy prices. And what they found was that actually for most properties, the more expensive of the retrofit measures weren't actually cost optimal over that time period. I mean, I guess that, with energy prices almost doubling, at least in the short term, that situation might well change. But the suggestion was that once you've got as far as your loft, cavity wall and draft reduction measures, then the best thing to do is to adopt one of these types of electric heating. And there was a mixture of low and high temperature heat pumps and storage radiators depending on the property. And also for most houses, using a time of use tariff was cost optimal. So some kind of heating over the nighttime period when electricity is cheaper. So why is all this relevant to air quality, you're asking? Well, so if we do think about deploying heat pumps, then that is going to change, it's going to change electricity demand massively. So it is going to massively increase our electricity demand to houses. We're displacing the use of gas with electric. But because heat pumps are overall pretty efficient, so they can be 3 times as efficient in terms of energy delivered compared to electricity used, then they are reducing our overall energy demand. And then I guess the overall air quality impacts nationally are going to depend really on how that electricity is being generated. So if you put a heat pump in your house, then of course locally air quality emissions will drastically reduce, because you won't be producing NOx from your gas boiler any longer, or from hot water generation. But for the meantime, at least, we are still producing in winter periods. We're still producing that additional electricity from natural gas power plants, and so until our energy supply chain or electricity supply chain massively shifts, then we still will have CO2 and NOx emissions from those power generation sources, but it just won't be locally. So whether or not that's an overall net change in terms of air pollution nationally will depend really on how quickly we shift to decarbonising our electricity supply, and also how successful we are at storing renewable energy from one season to another, because of course heat demand is going to come mainly in the winter, whereas solar energy production, for example, comes mainly in the summer. The other implication, I guess, from an air quality point of view of heat pumps is that they will change your temporal heating profile in your house. So this is basically showing a comparison of the typical way in which we heat our houses now with gas boilers, which is we put the heating on just before we get up, so that the house is relatively warm when we're getting ready for work or school or whatever. And we heat the house quickly at fairly high temperatures. And then it cools down again while we're out during the day, and then we heat it up again while we're for dinner time and while we're in the evening. And so we get these rapid heating periods with a dip in the middle of the day. The heat pumps, to take account of time of use tariffs, then the likelihood is we'll be looking at slower heating profiles and maintaining the temperature of the property in a more even way throughout the day. And that, I guess, will even out the electricity demand that heat pumps make, but it will also change the way the temperature in our house changes throughout the day. So heat pumps are providing lower grade heat with radiators typically around 35-40 degrees compared to the 55-60 that we might be using now. And so they will change this daily profile. And as I mentioned previously, they will also massively increase our winter demand for electricity, and that demand will have to be met. So there's been a few studies which have looked at people's response to changing their heating system to something that they're not used to. And this study by Tweed et al. In Energy Policy suggested that there were some positives, that people actually liked their spaces remaining at more constant temperature throughout the day, and they quite liked the more even distribution of heat that the heat pump gives. And one of the benefits of that, of course, is that if you are heating the house in a more even way, then you're reducing the kind of cold spaces that you might see in the house where you might get damp condensation forming, and that will have air quality implications. Also, you removing your gas boiler, so local any potential indoor emissions of air pollutants will be removed. And if there are any emissions caused, they will be at the electricity generating source. The negative comments around this were that people are used to having a living flame in their house, and they like radiant heat. And I think that 40% of you have got some kind of open fire or stove in your property. So one of the quotes in the paper was, "Oh, I can see that we'll keep running the wood burning stove, even though the house has a heat pump, because they're nice to sit round. It's nice to sit round a fire, and you've got the smell of ... You can put carcinogens in there, and the wood burning stove, and it smells and it's lovely." So people have a kind of emotional connection somehow to flames, and I guess one of the concerns is that at the moment, many houses, their flames are coming from gas fires. If we switch to electric heating and we remove gas from people's homes, then will they block up the chimney, as one or two of you have done, or will they basically replace the gas fire with a solid fuel burner? And therefore that secondary choice of heat is likely to have a big influence on air quality. So I don't know. I mean, personally, I really like to have a kind of even temperature in the house, and I have got a fake wood burner which runs on gas that it's never used basically. So I don't particularly like the heat that it gives out. But people have very different views on this, which will, I think, affect their behaviour and choices that they make. A second study on heat pumps was conducted by the Ayrshire Housing Study. It was slightly different because in this case they were replacing old storage heaters with air source heat pumps in social housing stock. And the reports from the residents were actually pretty positive in this study. So they all reported that they felt that they had improved thermal comfort levels. And interestingly, they all reported that they felt that the air quality in their homes had improved, which is interesting because they had storage heaters previously. And so they shouldn't really have had sources of air pollution from heat. So I think probably what this means is that they had less condensation, lower humidity levels from using the heat pumps, and that gave them the feeling that the air quality in their house had improved. There were also relatively few reports of being disturbed by noise. I mean, I'm not an expert on this. I mean, humidity levels were around 60%, which still seems relatively high to me, but this was obviously lower than they were used to from using storage heaters. And I mean, obviously, you know, since the death of the child from mold that was reported a couple of weeks ago, then obviously this has been really in the news in the last week or two. But reductions in damp and mold have got to be a priority really for improving our houses, because of course they impact on air quality, and there are many studies that have shown causal relationships between visible mold and exacerbations of respiratory diseases like asthma and wheeze, and particularly in children, where the effects can last, you know, right through into adulthood and can have long-lasting effects. There have also been associations found between workplace mold in buildings and occupational asthma, as well as links between mold exposure and allergies like allergic rhinitis, and effects on the immunological system. So exposure to mold is something that we really do need to tackle in our leaky housing stock. And exposure, you know, can be to multiple agents, so pollen, spores, bacteria, fungi, and microbes, allergens, etc. It's probably quite difficult to isolate individual compounds and their individual effects on health, but we just know overall that mold has a negative influence on respiratory health. So, I mean, I don't want to go into this in too much detail. I actually put these slides in before the court case ruling came out a couple of weeks ago, but some causes of mold are obviously poor ventilation, so poor circulation of air, low humidity air within houses, but also condensation on areas of houses which are colder than other parts of the house, or are poorly insulated, for example. So I know in this house, I had one wall particularly that was experiencing damp, and I've actually internally insulated that wall now. So if you have those cold spots or thermal bridges in your house, then you're more likely to see condensation there, and mold is more likely to form. And so it kind of follows that improving insulation and retrofitting of houses and providing heat more evenly across a house is likely to improve situations of condensation and damp. It's kind of a no-brainer that effective insulation and doing that evenly across a house has got to be a good thing. Obviously preventing water getting into the house and managing moisture through proper control of temperatures, so more even control of temperatures, and reducing stagnant air zones in the house. So in this sense, then, the more even heat profiles provided by heat pumps could be, in fact, beneficial. Okay, so now moving on to other sources. I'm going to run out of time very quickly. So I don't want to get necessarily into the hydrogen can of worms. It seems to be an extremely controversial topic, with many people arguing that we should never have hydrogen in our houses. I'll put my hand up and confess that we have had some money from a High for Heat project in Scape to design, in fact, gas fires that run on hydrogen, and there's an example here on the right. I mean, the reality is that hydrogen systems are going to be significantly less efficient than using heat pumps. So because we have to produce the hydrogen through electrolysis of water, then we lose some energy there compared to using electricity directly. And of course, a boiler is going to be significantly less efficient than a heat pump. So this is the negative side really of using hydrogen. I guess the positive side is that hydrogen is a way of storing energy from one season to the next. And so it removes some of the storage issues that we will have in terms of providing winter electricity to heat pumps. For the homeowner, a hydrogen boiler looks very much like the gas boiler that they used to. And so this might be more attractive to people. But overall, I think that hydrogen is not going to be necessarily the main way of decarbonising heat. One question is, hydrogen combustion obviously has got the potential to produce nitrogen oxide emissions, and is that something that we should be concerned about from an air quality perspective? I mean, the reality is that there are quite a number of different studies now that show that hydrogen boilers can be developed to be much lower NOx than the natural gas systems that they will replace. It's kind of counterintuitive because hydrogen burns with a very hot flame, and hot flames tend to increase production of thermal NOx. But interestingly, because with hydrogen there's no carbon in the fuel, we don't have to worry about carbon monoxide formation as we do with natural gas boilers, and we don't have to worry about particulates. And so that means that you can design the system slightly differently than you would for a natural gas burner. And it's possible through lean burn mechanisms and heat loss mechanisms to make boilers which are actually significantly cleaner than natural gas ones. So what's going to kill hydrogen probably is not really the air quality issues that will come with using hydrogen in the homes. It's going to be the supply of hydrogen, the costs of the fuel, and probably safety concerns of feeding it into domestic properties. Moving on to district heating. I mean, district heating has great potential really, because it can be so flexible. And even if we're using thermal generated power within a district heating system, it's possible to move the air pollution emissions away from residential areas. So, for example, in Denmark, incinerating municipal solid waste is commonly done in combined heat and power systems that then feed into a district heating network. And so people get hot water piped into their houses, and that there's no burner or boilers within their own properties, and that reduces their local air pollution and also the risk of carbon monoxide poisoning. The interesting thing is that when you burn even quite dirty fuels like waste or biomass at large scale, then that gives you more options for mitigating air pollutant emissions. And so overall, that would be much cleaner than burning solid fuels in individual properties. I mean, the other advantage of heat networks is that, you know, if we then start to decarbonize, then a heat pump or large heat pump systems could feed into heat networks. A hydrogen boiler could feed into heat networks, or even hybridized systems. And so they do give great flexibility. And just to show an example here of the one that's developed in Leeds. So here the hot water is coming from the energy from waste plant, which is basically the incinerator in East Leeds. And because this is a large scale plant, it has to meet the emissions limits of the Industrial Emissions Directive. And so relatively, it is significantly cleaner than burning fuel in individual properties. The pipe network, you know, there's a big infrastructure cost of implementing heat networks. But now this has been expanded. It's connected to 2,000 properties and buildings, and there are plans for further expansion. And eventually, you know, if the system expands more, then it's possible that other heat sources could be fed into this network with minimal air pollution effects, I would say. So really, we should be looking for synergies in climate and air quality solutions. And so how would that depend really on our choices for primary and secondary heating? I mean, the reality is it's actually not our primary heating choices which contribute the most to air pollution in the UK. Domestic combustion contributes only 4.5% of total NOx emissions. it's a secondary heating which is the main concern. So 25% of PM10, PM2.5, which is fine particle emissions, are coming from secondary heating of solid fuels, so wood and other solid fuels. And so actually secondary heating choices are likely to have a bigger impact on local air quality than primary heating choices. But the issue is that the two are related or could be related. So I guess you can think about your own choices. If your house was cut from the gas network and you were connected to an air source heat pump, what choice would you make? Would you basically block up your chimney and just use the heat pump? Or would you feel that the need for a secondary fire to kind of have that living flame feeling and to have a backup, for example, in a power cut? And so I think that those choices that are going to be made in the future will have a big impact on how much PM2.5 is produced at the local scale. I mean, if we do ever get hydrogen in the network, then I think, I was saying earlier that these kind of systems can be designed to be fairly low emission technologies. So I'm going to have to whiz through this because I'm running out of time. But basically, if we do get to a situation where people feel the need to keep a secondary heat source, this is potentially of concern from an air quality perspective. And it could be an unintended consequence of removing people from gas networks. So, I mean, I'm not saying that this will necessarily be a choice that people will make. It may well be that their houses are so well insulated and so evenly heated that they don't feel the need to include a secondary source of heat. But unfortunately, the data sort of suggests differently, that the stove sales in the UK are now at a scale of something like 150,000 to 200,000 units a year. So in the 5 years between 2010 and 2015, 1 million solid fuel stoves were sold. And people have that feeling that they want to have an attractive room with a living flame, or maybe people just don't have the choice to heat the whole house and they want the option just to heat one room to keep costs down. And so this choice to use solid fuel burners is going to have a dramatic influence on indoor and outdoor air quality. So I think I've already said that, but basically domestic stoves are contributing 25% to primary PM2.5 across the whole of Europe, in fact. And wood is not a clean fuel in terms of PM2.5. So these are emissions factors for different fuels used domestically. You can see that peat is actually the worst offender. Wood has higher PM2.5 in terms of grams of emissions per gigajoule of energy produced compared to even coal. And low smoke coal is insignificantly lower than that, and natural gas, you can't really even see the on the scale the PM2.5 emissions. So switching from a natural gas fire to a wood fire would have very negative impacts on PM2.5. And so there have been a number of studies which have shown the influence of wood burning on outdoor PM2.5. So this study by Gary Fuller's group, London, showed that wood burning contributes around 25 to 30% of the urban PM2.5 in London and in Birmingham. And the profiles here are showing kind of evening, particularly Saturday and Sunday contribution, which suggests domestic residential combustion. I'll skip that one. I mean, we actually did at Leeds some indoor studies. Well, I'm showing here some data from the Sheffield group, which actually looked at the influence of stoves on indoor air quality. And what they showed that when stoves are lit, the PM2.5 is 3 times higher than when the stove isn't lit. And PM1 is more than 3 times higher. So these stoves, particularly on refueling when the door is open, are actually flooding the room with fine particles, which then take quite a long time to decay, and so lead to overall increases in average concentrations. What's interesting is that the Sheffield group Chakraborty et al. Went back to these houses and put sensors in the homes to see if that would change people's behaviour, to see whether actually seeing these peaks in PM 2.5 on lighting and refueling the stove, whether that would persuade them to not use the stove. But in fact, what happened was the opposite. So here's some comments from that Sheffield study. What people were saying, and actually this is some of the feedback we got from this indoor study that we did. Got some really big peaks when we were cooking, particularly burning toast or frying food. And so there's not much you can do about that. So the stove peaks were very similar. So how bad can it be, really? So people get used to seeing spikes if you give them a sensor. They see spikes when they light candles. They see spikes when they're cooking. And the spikes from fueling the stove were similar. And so that made them feel more comfortable with using the stove. And in fact, using the DEFRA approved stove also made them think that that an official source had told them that was an environmentally friendly thing to do. So just briefly to mention this issues of scale in terms of using district heating compared to domestic heating. This is an open fire. It's kind of off the scale in terms of grams of particulates per gigajoule of energy. And this is the incinerator down here. So there's a huge difference in terms of the level of particulates produced as you move to the larger scale because of mitigation technologies like electrostatic precipitation and filters that remove the particles from incinerators and large power plant, which you obviously don't have when you burn domestically. I think I'm going to have to skip to the end, aren't I, because I'm running out of time. So that there are some strong associations with health of particulates from wood smoke that are emerging. And I think we need to do what we can really to encourage people to make different choices, to insulate the houses such that they don't need to use secondary heat very often, and that will have a big impact, I think, on local air quality. I just want to mention one final thing before I finish, which is another possible concern about blocking up people's chimneys to reduce heat losses, is that there are companies selling now flueless fires, which are marketed as being renewable because they're using renewable bioethanol. And there have been a couple of studies which have done chamber studies of these types of fires. I mean, anyone who knows about indoor air quality will probably be quite shocked by the concentrations here, but this is, they look nice. I've got one for the garden actually, but I would never dream of using it inside the house. But this is a flueless bioethanol burner. So it's been sold to use in the house without a chimney or with a blocked chimney. And this test case produced indoor concentrations of CO2 up to 20,000 ppm. CO well over the indoor limit of 10 parts per million, and NO2 1 part per million indoors. Also increased concentrations of volatile organics like formaldehyde. And yet these things are being quite heavily marketed as climate-friendly solutions for internal heating, which is, I think, quite scary. Another study here which shows the indoor peaks of CO2, in this case got to 3,600 ppm, and similar concentrations of NO2 of a part per million, and CO of 10 parts per million, which is, I think, is probably similar to what we would have seen in the Leeds underground internal tunnel about in the 1970s when we didn't have catalytic converters on cars. And so we really don't want to be producing these kinds of concentrations inside people's houses. So I'll skip to concluding remarks. I mean, I think the point that I'm trying to make is this quite a complex issue, and there are lots of interconnections between changes that will have to be made to primary heating choices due to the decarbonisation that we need to make for our heating sector, and the level of retrofitting that we implement in our houses, and how that influences the choices that we make for secondary heating. So does it mean that we remove the need for secondary heating, or does it mean that we will switch from gas to a solid fuel, or even worse, flueless choices for secondary heating. And the choices that we make all will have an impact on overall energy demands, as well as indoor and outdoor air quality levels, particularly secondary heating, I think, for air quality. And so we really do need to try and maximise the synergies that can be made here, and to somehow reduce the antagonisms that could develop. So retrofitting houses to reduce heat losses is kind of a no-brainer, at least the cheaper end of the retrofit options, and to discourage people, I think, from solid fuel secondary heating choices, it would be a good thing from my point of view, from an air quality point of view. So I think I'll better finish there, and we've got time for any questions.
Brilliant, Alison. Thank you very much. That was really interesting. So yeah, so thanks. And we've got a few minutes just for questions if anybody has any. If you just want to either put them into the chat or raise your hand, and I'll look out for you. Yeah, quite a lot of, I mean, there weren't sort of exactly questions in the chat, but quite a lot of interesting sort of discussion about how we might do things.
Yeah, so Kate suggested I should have asked what percentage of people were homeowners. I mean, that's an absolutely fair point, isn't it? How much control you've got over retrofitting your house. Should we have legislation to force landlords to improve quality of energy efficiency in homes? I
mean, interestingly, I mean, all those things are both true, and there are inequities there. But one of the issues is that we have quite a lot of home. 70% is owner occupiers, and a lot of those are very old, and a lot of those are owned by older people. So there are some significant vulnerabilities there.
Just reading a comment here. Resilience to interrupted energy supplies by having alternative means of heating feels to be increasingly relevant. Even in a passive house, having a wood burner as a backup is reassuring, even if it's rarely used. Yeah, okay. I guess if it's rarely, yeah, I mean, the wood burners are fine if you don't use them, I think. But I do see this as being a potential issue, particularly because we're seeing threats of blackouts now, and as we're moving towards higher levels of renewable energy into the system.
That was quite a big issue in the winter storms last year, northeast of Scotland. Large areas cut off, and a lot of those homes were then reliant on their local heating, and for a lot of those people that was wood burning stoves.
Yeah. Well, so I think, I mean, I didn't get as far as talking about this. Should we then make demands on the industry to actually develop mitigation strategies that we use in incinerators for domestic properties? I mean, domestic level electrostatic precipitators actually can be bought. So maybe if we can't make people give up their solid fuel burners, maybe we should make them remove the particulates before they release from the chimney. Is another option.
There's so just a question I've got. Well, it's not really a question. There is obviously this debate which goes on about heat pumps in poorly insulated homes, if they're not achieving their full COP, because the demand exceeds what they can do. It's a tricky balancing act, isn't it? I mean, I don't know if you've got any thoughts on that.
Well, I think that Bayes study suggested actually to get to a certain level of retrofit is all that's needed, really, so maybe we don't need to externally or internally insulate every house before people shift towards a heat pump, because particularly if the taxation system changes to benefit the use of electricity relative to gas, that actually it will become potentially slightly cheaper to use a heat pump, even a high temperature heat pump, in some houses. And so there are a lot of people living in historical properties that have got heat pumps. Although I've noticed that Janet's put a comment in here saying they had to get a noise survey. Wow, really? Yeah.
Well, no, interesting. We had an issue with planning in the Nidri Road passive house retrofit for stone tenement, and planning were difficult about air source heat pumps. Kate, I can see your hand up. Do you want to ask your question?
Yeah, just to add, really, if you can hear me, that as I put in the comments, that fabric retrofit to an extent, can you hear me?
Yeah.
Yeah, good. The fabric retrofit is also a health and wellbeing issue and an equity issue, and it's kind of really, if you've got decarbonised heat, then it's still absolutely an issue of whether people can afford to keep warm. And it's still not really framed like that by BEIS, which I think is a shame, or the CCC actually.
I totally agree. I mean, the data that came out from that recent report showing how much people are spending in poorly insulated houses, on their energy costs, and influences on, the damp and health implications of that. Support what you're saying. Yeah.
In a weird way, for more affluent people, the fact that energy costs are higher may become a great incentive to do something about it. Do you know what I mean? Okay, so you can afford that £4,000, £6,000 energy bill, but you don't want to. So the incentive to do that bit of retrofit, to do that external wall installation may become greater. That doesn't solve the problem for people in poor housing, tenants, and so on. But there is an interesting dimension to that, where suddenly things which you just looked at the payback and thought, well, that's not worth it, suddenly become more attractive from that.
Yeah, I had a bit of a row with a friend at the weekend actually. Well, I was just thinking actually, you're saying, we don't know how long we're going to stay in this house, but they bought a new kitchen which was probably 20 grand, I don't know, and they didn't ask that same question. So well,
it's a classic, isn't it? You will spend £3,000 on a sofa, and no one asks you what the payback of that is. So.
No, well, I guess you could take that with you, but yeah. Interestingly, I'm getting a new window tomorrow. My sofa badly needs replacing, but it seems like more hassle to me. But yeah, I mean, we do definitely need a change of attitude, I think, in terms of just improving the quality of housing stock, both for individual people who own their own homes as well as private and social housing landlords.
Grand. Listen, we are past time. We could probably continue the conversation. It's really interesting, but I think we'll probably wrap it up there because people have other things to go to. Alison, thank you very much. Really, really interesting talk. Thank you everybody for your participation and questions and comments. Really useful. This has been recorded, so people can kind of catch up on it later. And yeah, we'll start again in the new year with the next round of seminars. So yeah, thank you all very much.
Thanks everyone. Thanks for participating in the poll.